So our last set of notes, 22.3b, resampling and significance of experimental results. Resampling is a more exact way of determining if your data is statistically significant. What you would do is you would scramble the data, and that's called resampling. According to the Null Hypothesis, it makes no real difference which group the student was in. So this means that of the two samples, should be about the same no matter which 10 scores you put in each group. So yesterday, when we were looking at our notes, I had mentioned how even though this said 40 students, 20 took the prep course and 20 took the exam without the prep course, they only gave me 10 results. Now, it would be significant, it shouldn't matter which 10 scores I get from the treatment group and which 10 scores I choose from the control group. I should get the same results no matter what, especially if this isn't the entire group. You know, there are 20 people that took the course. We only are looking at 10 scores. It shouldn't matter which 10 we choose. We can use resampling to find the likelihood of getting a difference in the means that is at least as great as the actual difference. This is called a permutation test or a randomization test. We could use a random number generator on a calculator or a computer to choose 10 scores for each group, but doing them by hand is very time consuming. There are actually 184,756 ways to pick 10 of the scores out of the 20 in that category, if we're talking about that example from yesterday. If everyone in the class randomly chose 10 scores for group A and 10 scores for group B, we would barely be started on all of those possibilities. So let's suppose we did 90 resamplings of the data from those notes. So we did 90 sets of 10 scores. 90 times we chose 10. So 90 out of those 184,000. This data can be reported in a frequency table, histogram, dot plot. We have it in a little bit of a frequency table. So what we're doing is we are looking at, remember we took the 10 scores and we found the mean of the treatment group, the mean of the control group, and then the difference. So we're really looking at the difference. We had a positive 160 there. Now, the difference could be negative. So we have some intervals. So of those 90 times that we re-chose those scores, one of those times the difference was between negative 320 and negative 240 when we subtracted the two means of the two groups. That means the probability of getting a difference that fits in that interval would be 1 out of the 90 resamplings. Negative 240 to negative 160. The difference happening there happened 7 out of the 90 times. Here, between negative 160 and negative 180, happened 19 out of the 90 times. Negative 80 to 0 happened 26 out of the 90 times. 23 times we got between 0 and 80. Between 80 and 160, that happened 11 out of the 90 resamplings. 160 to 240 happened 2 out of the 90 resamplings, and 240 to 320 happened 1 out of the 90 resamplings. By the way, if they don't tell you how many resamplings, if they didn't tell me that they did it 90 times, that 90 times they redid this experiment, then I would add these, 1 plus 8 plus 9, 19 plus 26 plus 23 plus 11 plus 2 plus 1, and that would give me 90, which would tell me how many resamplings they did. All right, now we need to calculate the p-value. We're going to add all the probabilities of getting a difference the same as or more extreme than those we got comparing the treatment and the animal and the control groups. So in other words, if I look back at my notes here, our example that we got was 160. So we want to find the probability of getting something that is greater than or equal to 160. Well, 160 is right here. So greater than or equal to would be this category and this category. So I would take their probabilities, 2 over 90, and add it to the other probability, 1 over 90, and that gives me a result of 3 over 90, which is approximately 0.03. All right. So This is what's called a one-tailed test. Numbers more extreme than positive 160. We're only looking at the positive 60, or the positive 160. If the hypothesis was that it had some sort of effect, not necessarily a positive effect, but a positive or a negative, we'd have to use a two-tailed test where we would look both at the greater than 160 or less than negative 160 also, because that gives us our extreme values. So here's how we interpret the p-test. When you find your p-value, if p is greater than 0.1, that means it's not significant. That means that whatever the treatment was didn't seem to have an effect, so you accept the null hypothesis that there was no effect whether you used the treatment or not. If you get a value between 0.05 and 0.1, it is marginally significant. We say we reject the null hypothesis at a 10% level. If it's between 0.01 and 0.05, it is significant. You reject the hypothesis at the null hypothesis at a 5% level. And if p is less than 0.01, it's highly significant. You reject the null hypothesis at a 1% level, which means that your treatment had a pretty significant impact. So in this case, was the result statistically significant? Well, ours fits into this category because 0.01 is less than our p-value, which we got was 0.03, which is less than or equal to 0.05. So we have, because, I'm going to run off the screen here in a minute, because our p-value, I can't write and talk at the same time, our p-value was between 0.01 and 0.05, it is statistically significant. We can reject the null hypothesis at a 5% level. In other words, what that means is if we have to reject the null hypothesis at a 5% level, we have 95% confidence that our results are significant. And thus we've proven our point that whatever treatment we applied, in this case the extra course, does indeed make a difference with regards to the results that people get on the exam. Because resampling and calculating the p-score, I'm off the screen here, can be time consuming, even with a random number generator, textbooks often just tell you the mean and the standard deviation of all the resamplings. If you could do every possible resampling, meaning the 184,000, the mean of the differences would equal 0. The average of all the differences would equal 0. So 0 is usually the number given for the mean of those differences along with the standard deviation of the means. That means the standard error. The differences of the means are considered to be statistically unimportant if they fall within 95% of the mean differences of the resampling means. That means they are likely to happen even without treatment. Anything more extreme than that interval is statistically significant. And that's kind of what we need to focus on, the stuff that's statistically significant. We need to determine that. If they did all the possible resamplings of the 20 scores from the other side of this page and found that the resampling distribution for the difference of the means was normal with a mean of 0 and a standard error of 75, What interval captures 95% of the differences of the means? Now remember, the interval that we're talking about, remember our bell curve? 95%, there was our mean, and we went 2 to the left and 2 to the right. If we only went 1 to the left and 1 to the right, that would be 68%, but it was 2 standard deviations that way and 2 that way that gave us 95%. So if our mean is 0, we're going to subtract 2 standard deviations or standard errors, which would be 75. That gives me negative 150. And we're also going to do 2 to the right, which would be 0 plus 2 times 75. Oops, that's 150. And that gets me positive 150. So we would say negative 150 is less than or equal to x is less than or equal to positive 150. That is my interval that captures 95% of the differences of the means. Determine the experimental result's significance and state a conclusion. Because the difference of 160, because the difference of 160 that we got in our trial over here, remember the 160 stuff, is beyond the reasonable range. So reasonable range, remember the other day we talked about reasonable is 2 standard deviations below and above, then 160 does not fit between negative 150 and positive 150. It's outside there. So since the difference of 160 is beyond the reasonable or likely interval, the results are statistically significant. And we reject the null hypothesis. Okay, so our difference is outside of this range. If it was inside this range, we would accept the null hypothesis. We would say that the treatment really didn't have that much of an effect because the results we got fell in an expected or reasonable or likely range. Ours didn't, which means the treatment did indeed have an effect. So, our textbook company offers an electronic version and a paper version of the IM3 textbook. They want to know what effect, if any, the use of the electronic textbook has on student learning. A teacher with 2 classes of IM3 distributed paper textbooks to one class the first day of school and set up an online account for use of the students in the other class. After teaching the first module, the teacher gives everyone the same test and compares the results. The mean score for the class using the e-book is 81.7, and the mean score of those using the paper book is 77.9. The resampling distribution was normal with a mean of 0 and a standard error of 2. State the null hypothesis in terms of the differences of the mean test scores. The null hypothesis is that the differences between the mean scores is about 0. Meaning that there is no difference. Identify the treatment group and x bar sub t, which would be the mean of the treatment group. So, the treatment group is the group who used the electronic text. Used the electronic textbook, and the mean of the treatment group, or x bar sub t, I think they give it to us in the problem, is 81.7. Next, it asks me to identify the control group and the mean of the control group. Well, the control group is the group who used the regular paper textbook. Paper textbook. And the mean of the control group was listed as 77.9. Then it asks you to take the mean of the treatment group and subtract the mean of the control group. So 81.7 minus 77.9 equals 3.8. Now they want me to use the resampling distribution to determine the statistical significance of the experimental result. So I'm going to use the mean of 0, and I'm going to subtract 2 standard errors, and I'm going to add 2 standard errors. That gives me -4 here and 4. So in other words, -4 is less than or equal to x, which is less than or equal to 4. Since 3.8, which I got right here, is within this interval, it is likely the difference would have happened even without the books. Would have happened with or without, and I'm going to go to the next page, with or without, different books. We accept the null hypothesis which was that there would be no difference in the mean. And we say that there is no statistical significance between learning with the different books. Okay, so that's where we're at for this. That's the end of our packet. Yay! Over here, I don't think it's on there. It's on my page, but I don't think it's on yours. Your homework assignment, I'm going to write it at the top of the page just to make sure you've got it. It is in your textbook. It is the same page as last night's homework. Page 863. It is numbers 5, C, and D. Now you did parts A and B last night. 6, C, and D, as well as problem 7 and problem 10. So that's your last textbook homework assignment of the year. All right, happy studying.